talked about the parabola. We know we can recognize a parabola from an equation because with a parabola we have an x and y, but only one of them is squared. So when we have a parabola, it was either in vertex form y equals 1 over 4p times x minus h squared plus k, or x equals. So our y equals open up or down, our x equals open left and right. And those were the parabolas we studied with the conic section. We also looked at parabolas in conic form, which is not terribly different. Okay, the next conic we studied was the circle. And with the circle, we knew it was a circle because the x and y were both squared. But did you notice that every time it was a sum? And that every time we did a circle, the coefficients of that squared term, the x squared and the y squared, were always the same. So that's what created the circle. So today we're going to study the ellipse. It kind of looks like an oval. Tomorrow we'll talk a little bit more about the definition of an ellipse. But with an ellipse, how would we identify an ellipse? We can identify an ellipse similar to the circle. The x and y are both squared. An ellipse similar to a circle is still a sum. But different from a circle, instead of the coefficients being the same, they are different, which causes it to stretch. Stretch out horizontally or stretch out vertically. Okay, so the coefficients of the square terms are different. So let's look at the ellipse explicitly now. So the ellipse is defined as a set of all coplanar points such that the sum of the distances from two fixed points, called the foci, is a constant. So we call it foci because why? Because there are two focuses. So foci. Alright. So we have our pair of foci here. And it says that the sum of the differences between those two is constant. So if this were 3 and this were 3, that doesn't look the same. Does it look the same? No. Okay, so we'll call it, no, we can't call that. That'd be terrible. That means I drew this point in the wrong spot. Or one of the points in the wrong spot. Let's see if that looks closer. Do they look closer to the same now? Alright, so we'll call this 3 and this 3, so it has a sum of 6. So if I picked another point somewhere, say over here, this might be 1.5 and this might be 4.5, but the sum is still 6. So that sum of the two distances all the way around is constant, and we'll visualize this tomorrow. We'll play with some push pins and some string. Okay. So we have our foci, and let me draw those back on there. So we would have like a focus here, and another one here, and so that would be our foci. So just like with the parabola, the vertex was HK, just like with the circle, the center was HK. For the ellipse, we're going to stick with HK. Now, we have something called a major axis, and the major axis is just the longer axis, and the minor axis would be the shorter axis. When the ellipse is elongated horizontally, that horizontal axis is your major axis, and what we call this distance from the center to this endpoint or the center to this endpoint, we would call that A. So the length of the major axis would be A and A, so it would be 2A. Now this minor axis we would call, because it's vertical, we call it B. So this B and B would make 2B. Now, our foci. Our foci actually is the distance C. This distance C from the center to the focus is how we come up with our foci. And the way we find that is C squared equals A squared minus B squared. And that might seem a little funny to us. It's kind of backwards, but what would happen is B and C, if I connect these two, that would give me the A. Okay, so currently this is, we could shift this around. If I lifted this and connected that, you can see how they match, and I'm going to look for an animation that actually moves that around so you guys can see it. But what happens is A squared is equal to B squared plus C squared. And so that's where these come from. So C is that distance. So if it's elongated horizontally, this is the one we're looking at. If it's elongated vertically, this is the one we're looking at. But we always take the larger number and subtract the smaller number from it. Okay? So if this is HK, and we're moving left and right to get to our foci, we'll add and subtract that C to our X value at the center. Okay, now the vertices. The vertices are really what we call the endpoints of the major axis. Now for those of you that go home and you research math every night, I know, it's many of you. Or you might be right now pulling out your phone and verifying that what I'm telling you is true. Everybody calls the endpoints of the major axes vertices. And so to find them, we would do H plus or minus AK. But you may not find that everybody names the vertices of the minor axis co-vertices. Sometimes they just call them all vertices and lump them all together. So those of you that do that extra research tonight, if you see that, that's also acceptable. But if you are ever asked for the coverts, that's the endpoints of the minor specifically. So in this case, if it's elongated horizontally, that vertical axis is your minor axis. So that's what we move up and down from the center. Yeah, you add it to the Y. Good. Okay, so I went through all the aspects of a horizontally elongated ellipse. Let's see what you can do with the vertical. Now, we're still going to call this horizontal distance A, and we're still going to call that vertical distance B. So let's see if you can fill in the blanks. What would it be for those? And this is a worksheet that you got a couple weeks ago when you were doing Liv's classroom, which has come to an end. Some of you liked it, some of you were terrible at it.
There's no middle ground where you didn't enjoy it?
Those same people don't enjoy much math at all. So. I may do a survey to get some response from you. We'll probably make it like a survey monkey so you can do anonymous responses. And that way you can honestly tell me if you watch the videos and it won't be attached to your name. And that way gives me some better feedback on how I might change it. I already have some really good ideas. Next year everything's going through Blackboard so that it will show me if you actually open the links. Yes, sir.
Does the distance for the foci, does that have to do with anything from the Pythagorean?
It is totally Pythagorean theorem, yes, sir.
Silly choice.
That is exactly. Now with Pythagorean theorem, we always say a squared plus b squared equals c squared, but our a, b, and c are named differently here. Yeah. You need me to show you visually everything moving around to form that right triangle. I know you do. I will have that for you tomorrow. Okay, so the center is a gimme. It is always HK. This time our major axis is 2B. Or not. 2B. And our minor axis is 2A. Our foci. Our foci is going to be K plus or minus C, isn't it?
Yes.
Because those foci always lie along the major axis. Our vertices this time, if we're defining it as vertices and coverts, the vertices would be the endpoints of the major axis. So at this point, it would be a K plus or minus a B. And the coverts would be the endpoints of that minor axis would be H plus or minus A. Okay, so now we know about all the characteristics of the ellipse, but we totally ignored a major component, and that is our conic form of the equation of the ellipse. And do we see where the A and the B come into play? Okay, so the A is basically the reciprocal of the coefficient of our x, and the B is the same for our y. We will always have this equal to 1, and you will have to complete the square when needed. Okay? So we're going to look at some specifically. I do a problem, then you do a problem, then we do a more interesting problem. Alright. While waiting, congratulations to those of you that were on the swim team. Any swimmers in here?
Sam.
Nice job this weekend. Sam's not
No,
swimming.
I thought you were for real.
And then, congratulations to any cheer participants
Also
in here.
Sam.
Alright. Congratulations to any football players. Nice job, football team. And
Also, Joe.
also congratulations to any band members, because that was the most entertaining halftime show I've seen all year.
That was pretty good.
I totally enjoyed it.
The veterans did good too. That was interesting.
So,
I didn't.
alright.
Well,
And you know what? A lot of people didn't go. There was more room in the stadium to spread out. Like nobody was sitting in front of me. I was not packed in like a sardine. It was a slim crowd, but it was a great game. The football game was actually really good.
The first
I
half was
enjoyed the second half
actually
more than the
really
first.
nice.
I like to win, hefty.
The football itself.
But
We beat
No,
38
I meant like the game, not just like the
Okay.
first half I was surrounded with.
and then basketball starts this weekend, correct?
Yes.
Yeah. All right.
No, you didn't.
We play Saturday.
Hunter, what did you write?
All right. So here we go. This one's mine. So I know it's an ellipse. I know it's an ellipse because the x is squared, the y is squared. It's a sum, and they have different coefficients. The coefficient of my squared term is 1/9. Do you see it? The coefficient of my y is 1/4. Okay? So, the first thing I'm going to always do is start with the center. The center is the point to -1, so that's where I'll start. 2, -1, plot the point. Then I'll look and see, I can already tell this one's elongated horizontally because this is the bigger number. So A is 3. So I'll go out 3 units in either direction from my center and plot the endpoints of my major axis. Then I'll look at my B. My B is 2. So I'll go out 2 units in either direction from my center and plot the endpoints of my minor axis. Then I will do a terrible job trying to create an ellipse. I really hope you're better than me. These are really hard for me to draw.
That's
Okay,
really
that
good.
may be the best one I've ever done. I mean,
Okay.
I didn't even hit this point, but yes, I'm excited. Alright, so now I'm going to name my vertices. The vertices are the endpoints of the major axis. So we went out 3 in either direction, so we're adding and subtracting 3 to the x. That would be the point -1, -1, and the point 5, -1. My coverts, those are the endpoints of my minor axis, so I'm going up and down 2 from this point. So that would be the point 2, 1, and the point 2, -3. I got to do a little work for my foci. Okay, to find the foci, first I need to find c. And I remember that c squared is a squared minus b squared. So in this case, c squared is 9 minus 4. Every time you take the bigger one minus the smaller one. Okay? And then we take the square root of that. So c is what I really need. And c is the square root of 5. Now, I'm going out, left and right, from the center. So my foci, I need to take that c and add and subtract it to the 2. And since it won't simplify, I'm going to kind of take a shortcut and write it as 2 plus or minus the square root of 5. Now, if that actually was something that I could add, then I should separate it. So if I could like break it up into 2 plus or minus, let's say it was 7, then I should actually do 2 plus 7 is 9, 2 minus 7, yeah. But this one doesn't, so I'm okay. Any questions? Okay, if you have them, you're going to have them while you're trying this one. So please ask while you try this one. Okay? So you're going to do the center, the vertices, the co-vertices, the foci, and a sketch.
I can't draw. I'm kidding. Have a graph.
Thank you.
Just sketch, guys. Just put a quick axis on your paper and go for it. If you have great graph paper, fabulous. If you don't, a quick sketch, you can do it.
Oh man, that's not good. I lost my pages. Good. That first one was the best one.
Yeah, it won't happen again. I'm just not good at that.
Just the first one just.
What is that? Got it right.
Can we just like slow?
Oh, yeah. 0 plus 1, yeah. No, it's
There
plus
are
1.
How are you supposed to?
I know, but it's, you do opposites.
How would you know, how do you know which one's the major and the minor?
That's not fun, sure.
Like, I mean, you can, I mean, it won't tell you. So.
How many people even know that? A major and a
I
minor?
think we do.
She gets.
It's 5. Negative.
Do we need to know the major and minor axes?
Okay, so if I ask you the length of the minor axis, you would say 4. And if I ask you the length of the major, you would say 8. But generally, this is the info I'm looking for. The center, the vertices, the coverts. Now, you have to find C to be able to find the foci. So C is that difference in these two. 16 minus 4 is 12. So the square root of 12 is 2 roots of 3. Yes, ma'am.
So what exactly is the foci again?
Okay, the foci is really how you build the ellipse. The ellipse is the set of all points in a plane that are equidistant, whose sum is equidistant from 2 fixed points. So with a circle, we just have 1 fixed point, and the distance is equidistant. This time we have 2 fixed points, so the sum of those distances is equidistant. The sum of those is equal.
Okay, I'm confused. Like, wouldn't the co-vertices be like, over 4 for each?
Okay,
So it's
so
2A, right?
so this is okay. This length is 2a.
What? No, what?
The length of the whole minor axis is 2a.
Oh.
I can do that.
Forever.
All right. Yes, ma'am. I normally don't. I'm just doing it right now for clarity issues. So no, you would not have to. All right. So here it comes. You knew it was coming.
Wait, I'm not ready.
You know you.
I'm not ready.
See, I told you.
I'm not really ready.
I don't like it.
All right. So, first of all, how do I know it's an ellipse?
When it has two vertices, I mean, two variables are squared.
Squared. They're different, and it's a
Oh, crap.
sum. Okay. So those are the x and the y are being added
They
together.
have to be added.
Yes.
Okay.
Because if they're subtracted, it's our fourth choice, which is the hyperbola. Yeah. Okay. So it's squared, squared, different, sum. Okay. Totally not in the right form, but we have the
Square
tools in our
squiggles.
toolbox to do this. I always hated it when people, every meeting I go to, they say something goofy like that. What?
Put the tool
You
out.
have the tools in your toolbox to accomplish this task.
What?
All the builders.
Can we fix this?
All right. All right. This is more exciting than I thought. Okay, so we complete the square.
Let's
To
see.
complete the square, you group your x's, you group your y's.
Perfect square triangle.
This time, we have some coefficients to deal with. So, when we have coefficients, we know to complete the square, we must factor those coefficients out.
Minus 2x.
Alright, here is a common oopsie. We forget to factor it out of this. Do not forget. That will no longer be common.
Plus 4.
Alright, good.
Oh, 16.
So we're going to factor out the 16. So we're left with a 4.
Y.
Alright, so now we've got it in the right form.
2.
So here we take half, which is 1, squared is
Plus 2.
1.
I'm just kidding.
But to the other side,
I was doing
what do we add?
I was just over.
9. Did you catch that?
Yes,
Why
you
do we add
multiply it
9?
by the coefficient.
Good. What do I add here?
2 plus 2.
Try again.
It'd be 4.
4.
Did you
Okay. But to the other side, 64. Alright, so then math magic starts to happen, and it's so exciting the way it unfolds right before your very eyes. Alright, so here we have a trinomial which factors so
X
beautifully
minus 1.
into a binomial squared. And
X
once
minus
again,
2.
we have another happy trinomial.
Wow.
Now these better factor because we just completed the square to make them do this. That's why they do this. We force them to do that. Okay, and then all of this turns into 144.
Oh my, that's 12.
But I don't let, it can't equal 144. It must equal what?
The square root.
It must equal 1.
What?
1. Let's go back. Let's look.
Oh,
Look at this
yeah.
happy form. Must equal 1. Okay.
So now it's unhappy.
So it's not happy yet. You're right. It is unhappy. So the way we make it equal 1 is we divide every one of our terms. Every one of our terms
By 144.
by 144.
That makes everything harder.
No, it doesn't. It doesn't. Watch. This is where the math magic really happens.
Oh god.
Okay. 9
It's in the one.
goes into 144 16 times.
Really?
But why?
Because I learned division in 3rd grade, and that's how it works.
That's how it works, what?
And then 16 goes into 144 9 times.
It looks like
Now,
it's coefficient.
almost always they swap. You know why? Because I make up pretty problems.
Oh, shoot. Sweet.
And did you hear almost always? Because it's not always. It's almost always.
So wait,
So
what?
please still actually take a moment and go, does 9 go into this 16 times?
Does it 100?
Oh no, just
It does.
Sure it does. Because this is what you would do. You would not actually divide it. You would go,
You would multiply.
you would say 9 times 10 is 90. 90 plus 54 is 144.
that does not go out of my head.
You don't do that in your head?
No.
Alright.
I have to bring it down so much further.
Yes.
Are you always gonna give us problems that have nice numbers like
No.
She said.
Okay, no. Most of the time I will. Because the nice number problems graph pretty. And that's why I do some of this. And also, when I give you nice numbers, when you're done, you guys have a sense of confidence that you did it right. In reality, most things aren't nice. So if you were working with, and there is lots of application here, if you were working with a true application problem of this conic, more than likely it would not be nice. It would be ugly. And you'd have to be okay with that, and you'd have to feel confidence with ugly. And I'd go, ooh, I'm confident about this ugly answer.
I'm ugly and I'm proud.
A little bit of both. A little bit of both. Okay? Yeah. Alright. Alright. So, what have we studied so far?
I
The
sponge
parabola,
twice a
the
day.
circle, and the ellipse. Okay, I'm changing my directions a little bit on the homework because we took time out today to do the test, and you don't have as much time to get started on your homework. Normally, I make you do review of the parabola and the circle. Today, I'm just going to have you identify which ones you think are parabolas and circles, but when you get to the ellipse,
So.
you must give me all the info.
Okay.
Okay, so number 26, I printed a really old version. I don't really know why. Number 26 should be this, not what's on your sheet. So can you correct your sheet? And you're only to do the first portion here.
Sweet. Oh my Jesus.
That's it. 21 through 28. So for like number 1, Julian's going to put a P right here, and he's going to be done with number 1 because he knows this is a parabola. And the reason he knows is this y is not squared. So that's my only choice. I have one squared variable. He's going to write a P for parabola, have a little happy dance, and move on.
Yeah.
What?
Fergie.
Bro, you know what's a good song? Gabby Now, by Busta Rhymes. I don't know Busta Rhymes, but Busta Rhymes. Busta Rhymes. And that's all we changed was 26. You know it. Dude, you know most of it. Like, you sound pretty, you're accurate.
Okay.
So, wait.
Okay, guys, what did I tell you it was if it was subtraction?
Hyperbola. Okay,
So-
I'm pretty sure. I
Wait,
know
are we
that.
gonna be solving hyperbolas too?
Not tonight.
So I'm guessing.
Wednesday night.
So number 28 is a circle,
So do we, okay, so wait, so we do,
right? Okay, it looks like it.
so we do all of the top part and then like half of the second
I
part?
like there's all of it
No,
except for the graph.
your homework is only the top part.
Okay, cool.
There's the only thing except
Okay, so if you go to the website, there it is. It's just 1 through 28 tonight, guys.
Oh, this over here.
All right. So tonight's homework 1 through 28 is very mostly identifying little to do. Tomorrow, tons of practice.
Oh, yay.
Tomorrow, tons of practice.
So this half sheet is, the first part is the homework.